Hey everybody, want to introduce you to trigonometry, which among other things is the study of triangles. As we look into some triangles, wanted to give you a little bit of a heads up as to how things will be labeled. There's a convention that we label angles with capital letters and sides with lowercase letters. And there's also a convention that we use the same letter, an A here, for an angle and the side that's opposite it. And so angle C here, side C is opposite it. One other symbol that you'll see quite a bit is this little corner here. If you ever see that, that means that this angle is a 90-degree angle or a right angle. So a few things about triangles. All triangles have three angles, and those three angles always add up to 180 degrees. And so this equation, that the three angles add up to 180, is going to be a very helpful one for us. Let's look at two examples that use. So here's a couple of questions. The first question says that a triangle has angles of 27 degrees, 125 degrees, and what? And so in order to answer that question, we can use the equation angle of A plus angle B plus angle C has to add up to 180. And we know that the first angle is 27 degrees, and the second angle is 125 degrees. And so if we were to subtract those from 180, we'll get angle C. And so if we do that, 180 minus 27 minus 125 gives us 28 degrees. In this question, it says that a right triangle has angles of something, 48, and something. And that word, right triangle, is important. That means that one of the angles is 90 degrees. And then we can figure out what the other angle is by subtraction. So 180 minus 90 is 90, minus 48 more would give us 42. Another fact that is true of triangles, but only of right triangles, is the Pythagorean theorem. If you have a right triangle, then the three sides add up in this unique equation where one side squared plus the next side squared equals the longest side squared. And so a squared plus b squared equals c squared is a really useful equation because if you know two out of the three sides, you can use this equation to find the third. Let's see that. Here's an example that says a right triangle has sides of 12, 16, and something. And I put these in order, smallest, medium, and large. So if we want to solve for the missing piece, let's pull out the Pythagorean theorem. And we'll fill in the things we know. We know we've got a side of 12 squared and a side of 16 squared. And we need to figure out what that longest side is. So if we do a little arithmetic, 12 squared is 144, and 16 squared is 256. If we add those together, we get 400. And that means that c squared is 400. Taking the square root of both sides gives us a side length of 20. In this next example, we've got a side length of 9, something in the middle that we don't know, and a large length of 41. And so if we use that same equation, a squared plus b squared equals c squared, and fill in what we know the small side is 9, we don't know the middle side, and we know the large side is 41. If we do some more arithmetic, 9 squared is 81, 41 squared is 1,681, and so if we subtract 81 from both sides, we get that b squared is equal to 1600. 1600, if you take its square root, gives us a side length of, what is that, 40, I think? Yeah, 40. Now, we really get into trigonometry once we start talking about the ratios between different sides in a triangle. And so to do that, we need to consider one angle. And so Often we use the letter theta to indicate an angle that we're interested in. And we give each of the different sides of the triangle a name based on that angle choice. The longest side in a right triangle that's opposite the right angle is always called the hypotenuse. And then the other sides are called the adjacent side if it's right next to the angle, or the opposite side if it's across from the angle. And as soon as we've given the lengths of the sides names, then we can start talking about different combinations of them. And so one combination is if we take the opposite side and divide it by the hypotenuse side, that ratio is called the sine of theta. If you take the adjacent and the hypotenuse and divide them, that's called the cosine of theta, abbreviated with a COS. And if we look at the opposite side and divide it by the adjacent side, that's the tangent of an angle. Those three definitions, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Those are three that you need to commit to memory. Those three often are remembered with a little mnemonic called SOHCAHTOA. And so if you've ever heard or see this anywhere, it's referring to these. The SO of SOHCAHTOA is S for sine, O for opposite over hypotenuse. Similarly, cosine is adjacent over hypotenuse, that's the ka, and TOA part is opposite over adjacent for tangent. There are a couple other ratios that have names as well. For instance, if we look instead of the opposite divided by the hypotenuse, but if we take the hypotenuse and divide it by the opposite, that's called the cosecant. If we take the adjacent and divide it by the hypotenuse, that has a name as well, that's called the secant. And if we take the adjacent and divide it by the opposite, that's called cotangent. And while you could try to commit these to memory, you really shouldn't. It's going to be much more useful for you if you learn that cosecant is the reciprocal of sine, that secant is the reciprocal of cosine, and that cotangent is the reciprocal of tangent. All right, let's see that in an example. This example asks us to evaluate all 6 trig functions of the angle shown in this right triangle. What that means is we need to figure out what sine of theta is, what cosine of theta is, what tangent, cosecant, secant, and cotangent of theta are. All of those are going to be some sort of fractions, some sort of ratios between the 3 different sides. Before we get too far along, let's label the 3 different sides. The longest side in a right triangle is always the hypotenuse, and right now we don't know how long that is. The other 2 sides are based on our choice of theta, and theta was told to us to be this angle up here, and so 4 is the side that's opposite that, and 3 is the side that's next to or adjacent to it. In order for us to find all the different ratios, we're going to need to know that third side, and so let's find that a moment using the Pythagorean theorem. Remember, that was the one that said that a squared plus b squared equals c squared. In this case, we know the 2 small sides, and so we can put a 3 squared and a 4 squared in for a and b. And then we can do a little arithmetic and solve for c. 3 squared is 9, and 4 squared is 16. And so we've got 9 plus 16, which is 25. That's what c squared must be. If we take the square root of both sides, we know that c is 5. And now, in order to answer these questions, we simply have to remember each of the different combinations of values. So sine, remember that is from SOHCAHTOA, that's opposite over hypotenuse. And so the opposite side is 4, and the hypotenuse side is 5. Cosine is adjacent over hypotenuse, the ka part of SOHCAHTOA. And so the adjacent side is 3, and the hypotenuse is 5. Tangent is opposite over adjacent, the TOA part of SOHCAHTOA, and so that would be 4 over 3. The other trig functions, I would suggest that you memorize them as specifically the reciprocals. So cosecant, memorize that that is sine's reciprocal. And so knowing sine, all we have to do is flip that and write it as 5/4. And that's cosecant. Secant's reciprocal is cosine. And so if we know that cosine is 3/5, we know that secant must be 5/3. And cotangent and tangent are reciprocals. So if we know tangent is 4/3, we know that cotangent must be 3/4. Here's another common type of question. Find cosine of theta if we know sine of theta is 5/11. So to answer that question, we need cosine of theta. And so what we eventually need is to figure out what the adjacent side is divided by the hypotenuse. We are told that sine of theta is 5/11. Remember, sine is opposite over hypotenuse. And so we could say that the 5 represents one length of our triangle, the opposite side, and 11 is the hypotenuse. So let's see if we can label an angle and some sides. I know that the hypotenuse is the longest side of a triangle, and that must be the 11. Our angle, we could put either here or here. That doesn't really matter. However, if we know that the side opposite is 5, the way this is drawn, 5 is quite a lot smaller than 11. So if this is anywhat close to scale, I think I should put the 5 there. And that would make this theta, because we know the opposite side. And what we need to figure out is the adjacent side. Again, to find the adjacent side, we can use the Pythagorean theorem. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared. And in this case, we know one of the small sides, and we know the long side. And so let's label that as 5 squared plus something squared equals 11 squared. 5 squared is 25, 11 squared is 121. And if we subtract 25 from both sides, we get that b squared is equal to 96. That way, b must be the square root of 96. So we can write in here square root of 96. And our final answer then is going to be the fraction square root of 96 on top of 11. Now it's your turn. Here's an example like the first one we did, where you need to find all 6 trig functions of the angle shown below. Pause the video and see if you can do it yourself. First thing you would have to do is figure out what that third side is. You should do that with the Pythagorean theorem. That gives it a side of 5. Then we should label the 3 sides. And then finally we can fill out our table of all 6 trig values. Here's another example. Once again, see if you can find this one on your own. Go ahead and hit pause now and give it a shot. First thing you'd want to do is figure out what we were told. 9/40, that's opposite over adjacent. And so you could then label the different sides. If you label the different sides, we figure out the opposite, adjacent, and hypotenuse. We don't know the hypotenuse, so use the Pythagorean theorem to find that. And finally, you could fill in your table, or at least as much of it as you need. You simply need this part here. Hope you learned a little bit. Let me know if you have any questions. I'll talk to you later.